Hi, Year Nines, and welcome back to Science. Today we're going to finish off our content on vaccinations, and then we'll move on to the immunization debate. So you have already we've already discussed how a vaccine works, what is herd immunity, what is immunity, and the benefits of immunization. But right now I'm going to explain to you the difference between active and passive immunity. Okay, so slide 12. All right, so immunity is when you have protection against a certain pathogen or disease. And you can gain immunity in a few different ways. There's two main categories, active and passive immunity. And we can see that under each of these categories are two subcategories, natural and artificial. Natural and artificial. This is the textbook reference if you're interested. And this diagram is straight out of your textbook. Okay, so here we've got active immunity. Here we've got passive immunity. The difference is, in active immunity, the person actually has to produce their own antibodies against a certain pathogen or a certain, here it says antigen. Remember, antigen is just the certain part on the pathogen. It's like the tag or the barcode. Remember the barcode analogy that we talked about when you're scanning food products in a supermarket? It's just like one little part, normally a protein on a pathogen that the immune system can detect. And it gives it its identity. Okay, so active, the person produces its own antibodies. In passive immunity, you're actually receiving antibodies from someone else or from an external source. Okay, let's start with active immunity because vaccines falls under active immunity. So you can get active immunity naturally, and what that means is you are naturally encountering the pathogen, which means you're naturally going to get sick. So if I were to get the flu tomorrow, my body would have to kick in, the immune system would have to kick in, and the third line of defense, in particular, the B cells, would have to start pumping out antibodies in order to protect me. That's natural. Artificial is when your body produces antibodies because it's artificially encountering the pathogen. So what this means is, essentially, an example of this is vaccines, okay? So in vaccines, the pathogen is injected into you, usually in your upper arm, and that means you've now had the pathogen injected into you, and now your body has to respond by producing antibodies. So the difference between natural and artificial is the way that the pathogen is introduced into your body. So natural, your body naturally meets the pathogen because you naturally get sick. In artificial, someone has to inject you with the pathogen in the form of a vaccine. Okay, let's have a look at passive immunity. In passive immunity, you're receiving antibodies. Your body does not need to produce the antibodies, okay? So this can happen naturally when you get antibodies from your mum. So when you're growing in your mom's uterus, do you remember the placenta that you learnt about in Year 8 reproduction? The big, the sac thing that you get your nutrients from? So you actually, in addition to nutrients, you also get antibodies that cross the placenta into your own growing body, your fetus, the fetus that became you. In artificial passive immunity, you are receiving antibodies artificially. So that's, again, an injection. So that's one way that certain diseases can be treated. Okay. So just to recap, active is when your body produces antibodies itself. Passive is when your body receives antibodies. And natural is when the body naturally encounters the pathogen, in this case, or naturally is given the antibodies. And in artificial, either the person artificially isn't, well, in both cases, the person is being injected with either the pathogen or the antibodies. Okay, one more thing about this diagram is with vaccines, we've talked about how the whole point of it, the way that they work is that they memory cells are produced, which means that if I were to get immunized, so a few weeks ago, I got my flu shot. I've told you guys this already. If I were to encounter the influenza virus that causes the flu tomorrow, my body would already have these memory cells ready to go, which would quickly produce a lot of antibodies to protect me. However, in the case of passive immunity, where you've just been given antibodies, essentially, because your body hasn't had to make those antibodies itself, there are no memory cells produced. So if you were to encounter the disease again, your body would not know how to respond. Yeah. Okay. Hope that makes sense. So that is a little bit about the difference between active and passive immunity. Okay. I'm just going to go through a few more little things about vaccines. It'll just take a few minutes, and then you can answer the last question for lesson 9. Okay, so we've kind of already touched on this, but just to clarify, vaccination is when you're actually getting the vaccine injected into you, or you can take some vaccines are taken orally. Immunization is what happens in your body after you have received the vaccination. As in, memory cells have been produced, and now your immune system can recognize and protect you against that particular pathogen. So this is the process that happens in your body after you are injected with the vaccine. Okay, vaccination does not always guarantee immunity. So vaccines are pretty good. I was reading that the success rate is about, it's like 85% to 95%, but that means not everyone who gets a vaccine will actually get the immunity, but enough people in the population will. So that's where the whole concept of herd immunity comes into it. Okay. All right. Benefits of getting vaccinated include that you're protecting yourself against disease. You're helping to eliminate the disease from a population with the whole concept of herd immunity. You're helping protect the whole population. And if enough vaccines are given for a particular disease globally, you can actually help to contribute to getting rid of a disease altogether, which is what happened with smallpox, because there was a big global vaccination program against smallpox, and that helped to eradicate the disease, remove the disease completely. Okay. There's a lot of writing on this slide, but the main thing that you need to know is that it's always better to prevent a disease instead of treat it. So vaccines are a way of preventing a disease because you won't get it in the first place, and that's a lot better and a lot cheaper than trying to treat a disease once you've already got the disease, like with antibiotics or antivirals or other medications, fluids, whatever you need. Okay, this infographic, guys, summarizes really nicely some more effects, some more benefits. So if we have a look here, vaccines are a huge opportunity. If we were to scale up our vaccinations in the world's poorest countries, this could actually save $6 billion in treatment. And we could save 25 million lives. Okay. So we're really lucky in Australia. We have a very solid vaccination program. You can get free vaccines through the government, but not all countries are as lucky as us. And that's why a lot of diseases that are common in developing countries are not common here, because of really good vaccination programs. I've already mentioned as well, vaccines help eradicate disease. And here you can see some sample costs of vaccines, which are very, very cheap, only a few dollars or even less than $1. Okay, this is pretty interesting. And okay, this is the second last thing I need to touch on. So if we have a look, this is just for interest, guys. So if you have a look at this graph, each of these different colors represents the number of deaths from a different disease. So in orange, we've got the number of deaths from the diphtheria. In blue, we've got the number of deaths from tetanus. And then in light blue, we've got the number of deaths from polio, etc., and measles as well. Okay. And then this red arrow represents around the approximate time when vaccines were introduced for each of these diseases. So we can see that, for example, with measles, actually no, let's go with tetanus, it's a better example. So in 1946 to 1965, in that period of time, the vaccine against tetanus was introduced. And we can see that the number of deaths more than halved in the next time period, and then it kept going down. And that's the trend, the overall trend here. As soon as the vaccine gets introduced, the number of deaths starts to decrease, no matter what the disease is. And that just shows you again how great, how effective these vaccines are. Same thing with polio here. We can see that the number of deaths was increasing in the early in the first half 1900s to 1950s. It increased. And then as soon as the vaccine was introduced, it decreased. A different type of vaccine was also introduced, and it continued to decrease again. Now it's pretty much non-existent. Okay, the last point about vaccines, guys, is this is right here, the National Immunization Program. So I kind of mentioned it earlier, but this is all of the vaccines that newborns up to 4 or 5 years of age need to get. So it's very prescribed and it's very exact. The interesting thing here is some of them, you'll see, if you read this carefully, you'll see that some of the vaccinations are repeated multiple times, and that's because multiple doses are often required just to boost. They're called booster doses, and they just make sure that the antibody levels, the memory cell levels against the particular disease are at a good level. Okay, all right, guys. Can you please now, so you've already answered questions 1 to 4 for this lesson, and we've gone through them, but now your goal is answer this last question, compare active and passive immunity using the slides. And once you've done that, check your answer alongside my solution and upload all 5 questions up to lesson 9 assignment in Teams. And then once you've done that, check Teams again to see the lesson instructions for the rest of the lessons. Thank you.